So still working within force worksheet number 3. This time we're going to solve 7, 8, 9, 11, and 14. So number 7, if the same rocket, meaning this 50 kilogram rocket, is launched from Mars, what will its acceleration be? Meaning, because it's on Mars, there's less gravity. So we're talking about the same 50 kilogram rocket, 50 kg rocket. It's going to be launched straight up from Mars. So we're going to do all this. Let's just do this up here. So we've got still the same 990 newtons of thrust. We've got a 50 kilogram rocket. Fire. So that 990 newtons of thrust, we're going to solve this both ways again, is going to be spent overcoming force of gravity and then accelerating the force of the rocket. So 990 is going to be equal to 50 times 4, which will give us 200 newtons. 990 plus force of rocket. Subtract 200, subtract 200, we're left with 790 newtons is being applied to the 50 kilogram mass at some rate of acceleration. Divide both sides by 50, your acceleration will equal, divide by 50, divide by 50, 790 divided by 50 is 15.8 meters per second squared. The other way we can do this is we can say 990 newtons is going to be equal to the mass of the rocket times acceleration. Divide both sides by 50. 990 divided by 50 is going to be 19.8 meters per second squared. Remember, this acceleration includes a of g and a of the rocket. So let's subtract the acceleration due to gravity on Mars, which is 4, and we're left with 15.8 meters per second squared. Next up, we have number 8. A 7 kilogram block rests on a surface with 6 newtons of friction and is being pushed by a 55 newton force. So that 55 newtons first has to overcome that 6 newtons. So 55 minus that 6 is going to give us 49 newtons. That 49 newtons divided by 7 will leave us with 7 meters per second squared. Now, what we talked about up here was that total force equals force of gravity plus force of rocket, or total force equals friction plus the force of the object. So what we're seeing, I'm going to erase this, because I'm going to show it a little bit differently, is here's our total force, 55 newtons. It's going to be equal to the force of friction, 6 newtons, plus the acceleration and the force actually exerted on the block. So the force of the object, which is going to be 7 times whatever its acceleration is. So this is just to show you that we here subtracted 6, we got 49 equals 7 times a, right? Because that's gone, and this is that same answer, right? Just showing you how that system works. Erase. Good. So the answer there, 7 meters per second squared. 43 sorry about that motion there. A 43 kilogram block rests on a surface with 61 newtons of friction and being pushed by 23 newtons of force. What is its acceleration? Zero. If the push is less than friction, it's not going to move. That means you don't push hard enough. If you have a force that is smaller than friction, you cannot overcome friction. Where are you going? Nowhere. A 4 kilogram mass sits on a table that has 5 newtons of friction. If Maria applies 25 newtons of force to the mass, how fast will it accelerate? Once again, we need to say, okay, our total force is equal to the force of friction plus the force of the object, meaning the force actually accelerating the object, which will be the 4 kilograms times whatever the acceleration is. Subtract the 5, and we are left with 20 newtons equals 4 times a. Acceleration equals 5 meters per second squared. Right? Divide by 4, divide by 4. We just know that you can just take 25 minus 5, that's 20 newtons, right? But I'm showing you how to set up the problem so that we're thinking about this as a system with total force on one side and force of gravity or force of friction, and then the force moving the object on the other side. What will the acceleration be of the 6 kilogram block, meaning this one? So that 6 kilogram block is being pulled down by this block, which is being pulled by the force of gravity, acting on its 1 kilogram mass at 10 meters per second squared. That is 10 newtons. 10 newtons is traveling up this string through that pulley and pulling on this thing. So 10 newtons divided by 6 is going to be equal to 1.667. We can just say 1.7 meters per second squared. It shows down here.